All right, hello, this is Robert Quigley to talk about data-driven journalism and how everyone is a data journalist now. As you can see from this graphic, we start with data, we filter it, that's human filtering, and then we can visualize it or turn it into a story or both. And so it is very valuable now to have these skills, especially with digital journalism making data journalism so much easier and better. So why care about data? And where do you find data in the real world? The answer is it's pretty much everywhere. All you have to do is know that the government especially captures data on just about everything. So if you know where to look, you can find really great data to tell great stories. And it looks pretty much like digital Excel files. So if you've ever used Microsoft Excel, that's what it comes in. You just need to know how to use Microsoft Excel and how to turn it into something useful. It's useful to the public because there's all kinds of great information out there, from weather recordings to restaurant inspections to campaign finance numbers. And so the public needs to know this information, and you can give it to them in an easy to digest format. And the people who make it clearer for other people are journalists. That's what we do. We make everything clearer for the public. And so what do I mean by making it clearer for your readers? Well, imagine you're doing a story about something that's really high-end level physics, like quantum foam. Now, if you don't know, quantum foam is one of the smallest known things. There is the smallest known things known to human beings. How can you tell that in a story? Well, of course, in words, you could say that it's, this small using numerals. You could compare it to other things. But to really give the reader a chance to know, to wrap their minds around just how small something like that is, you could take the data and put it into a fun visualization. Here it is. All right, so what we're seeing is the relative sizes of things. And we have the human being compared to a dodo bird and a beach ball and a giant earthworm, which is really pretty large. But the reader can zoom in deeper and see, like, okay, in relative sizes, this is how big a white blood cell is to a human being. And now we're getting down to molecules and atoms. And then we can go way down into theoretical particles, all the way down to quantum foam. So that really gives the reader a pretty good look at it. Now, in another way, you could show how large something is. So if you're doing a story about the size of the universe, for example, you start again with your human being, and you go back up. And so we have everything from jumbo jets to the Eiffel Tower. And look at that, Texas is bigger than some planets. These are all relative sizes, remember. So there's our sun. There's stars that are much bigger than our sun. And as the reader zooms farther out in this thing, you can see, you go past nebulas and galaxies all the way to the size of the universe. So that really gives it perspective for the reader. And it's definitely changing our field. If you are good with numbers, if you know how to work with data, you can get a job. So this is what the data looks like when it first comes in. As you see at the bottom left, that's what it used to look like all the time on paper. Some organizations and government agencies are still going to use paper, so you have to kind of dig through it and then find a way to get that into an electronic format to make it useful. Top right is kind of what it looks like when it comes through on an Excel spreadsheet. This is actually pretty clean. If you look, the date formats are all the same, the names are all the same with last name first, and it has the D or R. Usually it does not come across this way. You have to know how to clean up the data and make it look all in the same format so that when you try to compute it or you try to actually visualize it, it'll work. So wrangling data, this is the biggest part of it. I really think that like 90% of working with data is getting that data clean first so you can do something with it. So you have to have skills in Microsoft Excel, including merging data sets and making calculations. It's really not that hard, but it does take some effort on your part. There are classes here at UT where you can learn how to use Excel better, including a data class right here in the journalism school. I really suggest you take it. But you could also just look on like lynda.com or on YouTube to find good tutorials on Excel. And if you have larger data sets, and I mean really large data sets, you'd have to use something like Microsoft Access, which is a little more complicated and a little more expensive. But if you have something like every single donation giving to the Democratic Party in the United States, you're going to need Microsoft Access. You need a good text editor. Most computers come with a very simple text editor. That's better than using Microsoft Word or something similar to that, because it won't try to format anything. It knows to keep things clean for you. So you can move around numbers and not worry about it trying to format into commas and all that kind of thing. So you need a good text editor to work with it. And you need to understand your data set. If you don't really understand what you're looking at, you need to figure that out first before you do anything else. It would help to have historical data or parallel data sets. By historical data, I mean if you're doing restaurant inspections, you don't want just what happened in the past 6 months. Instead, you want to have the data over time, and so you could show the readers or your viewers that here were the grades 2 years ago, here's how they've improved or gone downhill. For parallel data sets, you want to have things like if you got the restaurant inspections, you also want the data sets that show, and it might be on a separate complete Excel spreadsheet, but show the locations of those restaurants. And then you merge those together to create a map or something similar to that. So if you're going to report on data, you need to double check that you got the right data figures. Sometimes you will ask for these through an open records request, or they will just hand them to you, and you look at them and it's not what you were going for your story. So you just want to make sure that you're looking at the right thing. And this requires some math. Sorry, journalism majors, but math is important, and you need to make sure you got it right. Even if that means just going to a friend who's good with math to look over things, or having a math professor who you are on friendly terms with look at it for you, you really need to make sure you get it right. This is really, really important. It's like spelling a name correctly in a story. You might want to look into crowdsourcing. There are ways that you can get the crowd to work for you. So when I say crowdsourcing, here's a way that you could actually crowdsource data. The Guardian had, through an open records request, received Governor at the time of Alaska's Sarah Palin's emails. And there were 24,000 pages of those emails in printed form. They scanned them in and they asked readers to help them go through them. So they scanned actually 21,706 of them, and they were looked at by readers, and they were able to tag them with whether they were politically significant, about the environment, about money, about personal, whether they were funny or just not interesting. As you can see, not interesting was winning out. However, there is some like 4,760 that readers tagged as politically significant. The Guardian could then take those and look through them and see if there's something worth doing a story on. And they did do several stories based off this. It's a nice way to use the crowd because the Guardian is a really big news organization, but going through 21,706 pages would take a lot of resources and a lot of time. So here's another way you could invite the crowd to play a part in your data journalism project. This is from BBC News Magazine. They did a story on this huge survey that was done with 161,000 people in Great Britain on their lifestyle and what class they are. And so what the BBC did was they took that data and set it alongside this fun little thing where you could take a test. So you tell the BBC about yourself. You put in how much you earn, whether you own or rent property, what that's worth, if you have any savings. And as you can see, as you're doing it, it's actually changing the visualization over on the left. So I am a farm worker, so I'm going to go ahead and put that. I go next, and I go to listen to jazz, of course, and I do arts and crafts because I'm super crafty. And as you're going, it tells you exactly at the end what your level is, and I'm technical middle class according to them. And that's kind of interesting because it takes the data set that is given by the crowd and it puts it as a parallel data set to the data set they got from the survey and gives you fun, interesting results that were easy to do for the user. And that's really important. And if you haven't used web-based conversion calculators before, you really should look into that when you're trying to convert something that's relatively difficult, like Fahrenheit to Celsius. Google has everything you could possibly imagine for converting things. Don't try to do it on paper and pen. It's going to frustrate you and you'll probably make mistakes. Definitely check with your sources if the numbers are funny. So let's say you're doing restaurant inspections and this restaurant that's very, very popular has a 9 rating, as in the number 9, and out of 100. And usually they're in the 80s or they're in the 90s. Now, you could just do a story on, oh my gosh, look how terrible this restaurant is. Or you could double check and make sure that there's not something wrong with that, like they forgot to put a 0 after it. Maybe it was supposed to be a 90. So make a call to your source and make sure it's correct. Definitely use clear wording and labels. We're journalists. We should be able to describe things in a way that makes sense to people. And this is something that gets overlooked a lot when I see data either visualized or told in a story online, is that we get so plugged into our data and so into that project that we forget that we're trying to explain this to people who have not seen this data before. And use smart design. There's a lot of great things you can do with design once you have that data. So the tools you need to know, there's plenty out there, but some of the more popular ones are Google Fusion, Many Eyes, and Tableau. Many Eyes is by IBM. They're just nice little programs that allow you to take simple data sets and turn them into something that the reader can see. And great design really matters. I know I've said this twice, it really, really matters. This might be my favorite data visualization of all time. The New York Times during the Olympics was trying to find a good way to show off just how fast these 100-meter sprinters are. I'm going to go ahead and play this. I think it's amazing.
Just how fast was Usain Bolt's gold medal sprint? Let's put him on a slightly bigger stage and see him race against every Olympic medalist since 1896. This imaginary race, assembled using runners' average speeds, reveals just how much faster sprinters have become. A few lanes over, we see another Usain Bolt, who dominated the field in Beijing in 2008. Almost 10 feet back, Carl Lewis, gold medalist in Seoul in 1988. He won in 1984 too, one of just a handful of sprinters on this track twice. As we go further back in time, we pass more of the fastest sprinters in history. Jim Hines, the first man to break 10 seconds in the Olympics. Jesse Owens, who won 4 golds in Berlin in 1936. Archie Hahn, the Milwaukee Meteor, who won 3 events in 1904. And finally, near the end of this track, we have Tom Burke, who won in Athens in 1896. His time, 12 seconds, puts him more than 60 feet behind today's winner. So what can we take away from this picture? For one, a lot of these sprinters are from the US. Although Americans have had a rivalry with British sprinters, and, more recently, Caribbean athletes, nearly half of these runners are Americans. But we can also see that glory is fleeting. Repeat performances are rare. There's been a new winner on the podium in all but 3 Olympics. But to get a little bit more perspective, let's see how some of America's best young sprinters would fit into this group. Here are the fastest kids at the 100-meter dash at different ages, as recorded by the Amateur Athletic Association. Obviously, they're way behind today's athletes, but they're not as far behind as you might expect. America's fastest 8-year-old did the 100-meter dash in 13.5 seconds, which would have put him less than a second off 3rd place in 1896. Not bad for grade school. And the record for 15 to 16-year-olds is a 10.27. Good enough for a bronze as recently as 1980. Still, it's not like those Olympians were slow. Despite more than a century of improvements in nutrition, fitness, footwear, and track surfaces, the difference between today's athletes and the fastest humans of the 19th century? Just about 3 seconds.
So as you can see, great design really matters there. It really shows off what we need to see. It's so much more interesting than just telling the story with numbers and text. You can use data for short form projects or for something that has a longer shelf life. Programming skills do help, and I know that probably scares a lot of you, but it does. Also, all you really need though is curiosity. And anyone can do this. It just takes interest. If this is interesting to you, pursue it. Find out how these things work. And even if you're like, I'm not going to be a data journalist, you still need to understand and report on data. Almost every story you run across is going to have a data set of some kind. You can't just ignore that. You're going to have to tell a story based off what you're seeing in a spreadsheet.